Hey guys, so in today's lecture, we are going to discuss the third main system, that is furnace. Before this, we have discussed boilers and steam system. So, we have seen how we can save the energy in boilers and in steam system. Now, we will focus our goal on next system, that is furnaces. So, before starting furnaces, we will understand what type of furnaces are there and how they work. So, we'll see first classification of furnaces. So, what is furnace and where it is used? So, this is the syllabus which we are going to study: classification, then fuel economy measures, and then excess air and heat recovery, then cupola furnace, and forging and heat balance sheet equations. So these are the topics which we are going to discuss in this system furnaces. So these are important points which we are going to discuss. So let's start with furnace. But what is furnace? So furnace is another thermal utility. So furnace is also a thermal utility which finds its major application in industries. So furnace is defined as a device used for heating the materials. So a device where we use to heat the materials so that heat is not dissipated easily to the atmosphere. So it is a so it is used for heating materials. So basically we will classify furnace on the basis of four factors. So that is fuel used for combustion. So what type of fuel is used? So there are so many fuels. Then mode of charging of material, how we can charge the material. Then waste heat recovery mode, how we can recover the waste heat, and mode of heat transfer, how heat is being transferred. So first is fuel used for combustion. So different fuels, namely that is coal, then oil or gas, are the fossil fuels which we use. That is coal, oil, and gas. So it is based on coal fired furnace, oil fired, or gas fired furnace. So based on that, it is classified. So oil means petroleum or diesel, and gas means natural gas or petroleum gas. Then electrical fired furnaces are also getting attention day by day. And electrical furnaces are also a good source. So electrical. So these are on the basis of fuel used. Then next is on the basis of charging of material. So on this it is classified on, that is batch type furnace and continuous type furnace. So how the material is charged means, batch type means if a product, if any specimen is being heated, and after that the furnace is cooled down, and then again it is heated, it is batch type. Then in continuous, that continuously the furnace is on and you are just changing the specimen, so that is continuous process. So on this it is classified. Then next is based on waste heat recovery mode. So on this it is classified as recuperative or regenerative. So on this recuperative and regenerative type of furnaces are there, and this also how wastage heat is being observed, been absorbed and can be used. So on that it is classified. Then the last is mode of heat transfer. So so as we know that how heat can be transferred. So on this it is said that open fire place furnace. That is open fireplace furnace means directly uh, it is coming in contact with the fire, and it is open fire, and another heated through medium, and the other is heated through medium. So if there is some medium in between, then it is called heated through medium. If the specimen is coming in directly in contact with the fire, then it is called open fire, and if it is coming via some other medium, then it is called heated through medium. So these are the main classification of furnaces. So next we are going to see furnace efficiency methods. So what are the various efficiency measurement methods of furnace? How we can calculate the efficiency? So these are the four efficiency measurement methods. So that is complete combustion with minimum excess air, then heat distribution, temperature control, and waste heat recovery from the flue gases. So if the combustion is carried out with higher excess air, so it will reduce the flame temperature, furnace temperature, and heating rate. So if too much air is used, then the temperature will be reduced. So the amount of heat lost with the flue gases depend on amount of excess air. So on the other hand, if the excess air is less, so if excess air is less, then unburnt component in the flue gases will increase and would carry away the flue gases through the stack. So, so if there are more air, then also uh, the temperature will be reduced, and if the air is less, then the combustion doesn't take place completely. So we need an optimum solution. The optimization of combustion air is the most attractive and economical measure for energy conservation. So the impact of this measure is higher when the temperature of the furnace is high. So this impact is more high, and it is visible when the temperature we are saying very high. So in the case of furnace carrying away flue gases is 900 degrees Celsius, then the percentage of air lost is also high. So suppose let's plot a table. So if the flue gas is at 900 degrees Celsius temperature and excess air is suppose 25 percentage, then percentage of total heat lost is 4 percentage heat is lost. 4% heat lost. If we are saying 50% excess air, then 5% heat is lost. If 75% excess air, then 6% heat is lost. And if 100% excess air, double is the excess air, then 7% heat is lost. So as we can see, the heat lost is very much high. Then next efficiency method is heat distribution. So for proper heat distribution, the following points we are going to discuss with reference to the burner and furnace design. So how we should design the burner and furnace. So the flame of burners should not touch any solid object and should propagate clear of any solid object. Any obstruction deatomize the fuel particles and it creates the black smoke. Then the flames of the different burners in the furnace should not touch each other. They should not touch each other. Stay clear of each other. So if they intersect, inefficient combustion would occur. Means if there are two flames and if they are intersecting each other, then inefficient combustion would occur. It is desirable to stagger the burners in opposite direction. So it is desirable that we stagger the burners in opposite direction. That is in such directions opposite. So the burner flame has tendency to travel freely in combustion space just above the material. So in small furnaces the axis of burner is never parallel to the earth but always in upward angle. So it is always in upward angle. If this is the tray and this is the burner, so it is always in upward angle. So flame should not hit the roof. So it should not hit the roof. So if the flame impinges on the refractories, the incomplete combustion products can settle and react with refractory constituents at high flame temperatures. So these constituents can react with the specimen. So it should not impinge on the refractories. So this is the flame placement and furnace placement, how we can improve the efficiency. Then next method is temperature control. So how we need to control the temperature to obtain the maximum efficiency. So operating at very high temperatures than optimum temperature leads to heat loss. Will lead to heat loss, excessive oxidation, decarbonization, as well as overstressing of the refractory. Overstressing of the refractories. These controls are normally left to operator's judgment, which is not desirable. To avoid the human error, on and off controls should be provided. So automatic on and off control should be provided to resolve these all issues. Then the next then the next point is waste heat recovery from the flue gases. So from furnace, the products of combustion live at very high temperature. So then the normal or stock temperature. So sensible heat loss in the flue gases while leaving the chimney carry 35 to 55 percentage of heat input in the furnace. So the higher the quantum of excess air and flue gas temperature, the higher would be the waste heat availability. So waste heat recovery should be considered. After all, other energy conservation measures have been taken. So minimizing the generation of waste heat should be our primary objective. So the sensible heat in flue gases can generally be recovered by following methods, that is preheating, charge preheating. Second is preheating of air, that is air preheating. And third is utilizing waste heat for other processes. So by these three means we can utilize our waste heat. That is, we can heat the charge or air, or we can use for other processes. So these are the main furnace efficiency methods which we have discussed. That is excess air, heat distribution, temperature control, and waste heat recovery. Now, next we are going to discuss performance measurement. Performance measurement and furnace efficiency measurement methods. So, the performance measure of a furnace is measured in two parameters. So, we measure in two parameters. So, first is furnace efficiency of furnace, and second is specific energy consumption, SEC. So efficiency, as we know, that it is always defined as output upon input. So the ratio of heat output upon ratio of heat input. So we will get the efficiency. So what is output and what is input here? So the output here is that the heat gained by the materials, how much heat the materials or the specimen is gaining. So in kilocalorie. So that is output. And what is input? The heat input in the form of fuels. So that is coal, petroleum, oil, gas. So how much uh, energy we are generating by burning the fossil fuels, and how much energy we are getting in kilocalories into 100. So that is efficiency into 100. And another performance measurement is specific energy consumption. So this is defined as fuel consumed upon quantity of material processed. Fuel consumed upon material processed. So this is specific energy consumption. So these two parameters are very much important. The next, now we'll see how to measure the efficiency. So as we know, as I have written the formula of heat output upon heat input. So there are two methods to measure the efficiency. So the formula which I have written is direct method. So here directly we are measuring the efficiency. So here the heat formula, heat output upon heat input. So what will be the formula for heat? So the heat formula is denoted by Q will be mcp delta T, mcp into T2 minus T1. So heat transfer to the materials in the stock. So how much is the output? So whatever the temperature of the material is starting, and how much temperature of that material is raised. So that is the heat output of the material. So from that we can get the formula for the efficiency directly. Now there is also another method to find the efficiency, that is indirect method. So in this method uh, all the losses are considered which occur in the furnace. So the accurate efficiency is calculated. So what is the drawback of direct efficiency method? That we do not know that what are the reasons behind that loss in efficiency. So here we are first calculating losses, and then we will deduct these losses from 100%. So we will get the efficiency. So which are these losses? So there are total 6 losses. So these losses we will discuss in the next lecture. So it is due to loss in flue gases and other also moisture and opening and the furnace skin. So these losses we will discuss in next lecture with the formula and also with an example. So this indirect method we will discuss in the next lecture. So thank you very much.